Hello again, pre-calculus students. Now we're going to do the next section of our text on inverse functions. So I'll share my screen with you and we'll get started. So inverse functions undo each other. For example, y equals x squared and y equals the square root of x, where both of those functions are defined, they undo each other. In other words, if you take x equals 3, you get y equals the square root of 3. You square it and you get 3, so you end up with where you started. So our definition of inverse functions is if f of g of x gives you x and g of f of x gives you x, then they are inverse functions because we started with x, we got g of x, and then when we took f of x, we got back to x, which is where we started. Same here. And you can write them this way. Don't think of that as a reciprocal, like 1 over g. In function notation, that means g inverse. To find an inverse function, you probably learned this in an algebra class. You swap the x and the y value in the function and solve for the new y. So if we have the function y equals 2x minus 7, we swap the x and the y and we get this equation. Now I solve for this new y. And just to show you that this works, let's start with x equals 3. If x equals 3, 3 halves plus 7 halves is 10 halves, which is 5. Stick that 5 into here. 2 times 5 is 10, minus 7 is 3. So I got back to the 3 I started with. If I could put 5 in here, if we start with 5, 10 minus 7 is 3. And then 3 halves plus 7 halves is 10 halves, which is 5. So we're back to where we started. So these two functions are inverses of each other. We can confirm that they're inverses by making sure that both f of g of x and g of f of x both give us x. Now I'd like to show you, you might recall from your algebra days what inverse functions look like when they are graphed. So I'm going to share a different screen with you. And this is Desmos. So here's y equals 2x minus 7. Here's y equals 1/2 x plus 7 halves. And you'll notice there they are. What you might remember from your algebra days is that inverse functions will be reflections over the line y equals x. So if you take that green line, this original one, I should change that color. Can I change that color? I'm not sure how to change that color yet. But anyway, if we took this green line and we reflected it over the red line, I'm sorry, or reflected it over y equals x, you would get the red line. Okay. So now let's go back to my slides. How can you tell if a function has an inverse function? Well, if the inverse is a function, then the inverse must pass the vertical line test. And you reflect that over the line y equals x. So what you get is this. If your original function passes the horizontal line test, in other words, it intersects the graph only once, then its inverse will pass the vertical line test and will be a function. You can almost always find an inverse, but is the inverse a function? So let's see. Here is a example. Example is a word I created. It's a combination of an example and a sample problem. It's a example. So here's y equals x squared. We can tell by looking that it's a function. It passes the vertical line test. Well, also it's a parabola, so it's, I mean, a polynomial, so it's automatically a function. But you'll notice that it fails the horizontal line test, which means that its inverse is not a function. Let's take a look at Desmos again and see what we mean by that. So here's y equals x squared. The inverse would be x equals y squared, but notice that I had to limit y being greater than 0. So I'm only looking at this part, the flashing part of the original parabola. Because if I flip this over the line y equals x, if I flip this parabola over, I would get a parabola that would look like this. And then it would fail the vertical line test. So the fact that this original parabola fails the horizontal line test means the other parabola would fail the vertical line test. Well, because we want the square root function to be a function, we limit it. When we say square root, we mean the principal or the positive square root. So if the y values have to be positive here, then the x values have to be positive here. So to get the square root function, we have to limit this parabola to this one. Now we have a function. And that's all I have for you in this lesson. You've seen all the functions I wanted to show you in Desmos. We can go over that more in detail in class. Other than that, have a great day.